Hey guys, it's Wilman here. I'm just going to record a short little video about our next topic in our geometry unit in pre-algebra, which is going to be finding the surface area of shapes. So if you remember from last week, we talked about finding the area of shapes, okay? And the types of shapes we were interested in were like squares, rectangles, triangles, and like circles, for example. With surface area, we are now going to consider 3D shapes or three-dimensional shapes. These are actual shapes that you could like hold in your hand. So here are a couple examples. Question 1, this circular shape is called a sphere, and a sphere would be kind of like a basketball. Question 2, that's kind of shaped like a dice, like we've used in class before. Or just like a generic cardboard box or something, okay? So these 3D shapes, we're actually going to calculate the surface area. So what do we mean by surface area? Well, area talks about how many units are occupied in a space. So from last week, if I'm looking up at this triangle, I want to know how many square units are occupied in this space right here, that orange. Surface area is the same thing, except if you're looking at question 2, we want to know how much area is occupied by this part of the box, 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 and this part. Surface area refers to the area of the whole entire outside, all of its sides together, okay? So it's going to be similar to last week, but there are also going to be some new things. And the easiest way to explain surface area is just going over a couple examples and some specific formulas, okay? So we're going to start with one of the weird formulas first. That is with question 1, with a sphere, like a basketball. So here is our formula for a sphere's surface area. Surface area equals 4 pi r squared, okay? And again, r is the only variable. It refers to the radius. So looking at our example, that red dotted line is actually the diameter. Remember, the diameter is how far across from one side to the other through the middle the sphere is, or the circle is. So to find the radius, it's actually half of the diameter. If the diameter of the sphere is 4, we know the radius is 2. So I'm going to rewrite this equation, 4 pi. But instead of writing r, I know the radius is 2 because that's half of the diameter, okay? And then I got to square it, okay? All right, so if you have a calculator handy or on your phone, you can do it too. You're going to take 4 times pi. Remember, pi is essentially 3.14. 3.14. So if you take 4 times 3.14, you're going to get 12.56, okay? And you want to take that times, well, 2 squared. 2 squared means 2 times 2, and that means 4, okay? And if we do 12.56 times 4, that's going to give us 50.24, okay? So since we are talking about surface area, area is always your units squared. So we're going to put m squared. M stands for meters. So the surface area of this shape is 50.24 meters squared, okay? So again, when you are specifically given a sphere or that basketball shape, you're going to use this formula right here. That would be a good one to write down in a notebook, on a sheet of paper, or just remember, okay? That's one of our important formulas. Okay, let's go to question 2. Question 2 is a box. So you imagine like a cardboard box, something you would get in the mail if you ordered something from the internet, Amazon, whatever. We're going to find the surface area of this shape, okay? And the way we're going to do that is by using this formula. Surface area would equal P times H plus 2 big B, okay? P, in this case, is going to stand for perimeter. Perimeter of the base. Remember, perimeter is how far or how much something is around the outside. The measurement of something around the outside, okay? H. H stands for the height. And that big B at the end stands for the base or the bottom. So looking at our shape here, let's first find the perimeter of the base, okay? I'm gonna say this is my base. If you would set this box on the ground, this would be the part that's on the ground, the base, okay? What is the perimeter? How far around that purple is it? Well, I know this side right here is 5, so that means this other side is 5 centimeters. Since I know this is 4 centimeters, I know this part here is also 4 centimeters. And same thing with the side across from it. So my perimeter is 5 plus 5 plus 4 plus 4. Okay, that's my perimeter. My height, how tall is this box? If I start at the base, how tall is it? Well, it's this height right here, 5. So I'm going to take that times 5 plus 2 times the base, okay? And when we talk about the base, I should have wrote area. We want to know the area of the base. So since my base here is a rectangle from last week, to find the area of a rectangle, all you got to do is this side, the base, times the height. So 4 times 5 is 20. So since I'm kind of cut short for room, I'm going to put a times 20 right here, okay? Let's do this. Just give me a second here. This will make it easier for us to see. There we go. Plus, I said 20, or 4 times 5, okay? So all we got to do now is do some calculations here. So 5 plus 5 plus 4 is 18. The purple is 18. Take that times 5, and then we're going to add that to 2 times 20, okay? All right, one more step of calculations. 18 times 5, I believe that's going to give us 90, plus 2 times 20 is 40. That's going to equal 130 centimeters squared. That is the surface area of that box, okay? And you can check it. If you would take each of these sides of the boxes individually and find their area and add them all together, you would get 130 centimeters squared, okay? Same thing that we got. All right, so I would say your next key formula that you should write down should be this guy right here, the one that we just used. Perimeter times height plus 2 times the base, okay? This is going to be useful anytime we have a prism, okay? So I'm going to write anytime we have a prism, okay? And prisms include shapes like these boxes here. They include triangular prisms, which kind of look like this here. Okay? We'll do a triangular prism example here towards the end. But for most boxes and triangular prisms, that's the formula you're going to use, okay? All right. Number 3 is the exact same type of question as number 2. So I'm going to skip that one. We're going to go to number 4, a cone. So to do this, I'm going to have to slide my computer screen down, so it's going to delete what I currently have on the screen. So if you need to take a note over it, pause the video. Otherwise, I'm going to delete it. Okay. All right, here we go. So number 4, if you look at that shape closely, I'm hoping that you realize it's actually an ice cream cone with no ice cream in it, okay? It's a cone. So a cone is another special one that we have a special formula for. So the surface area of a cone is going to equal pi r squared plus pi rs. So remember, r stands for the radius, so there must be a circle in here if there's a radius, and the s stands for slant height. And what slant height is it means if you focus on the tip of this cone right up here, slant height refers to the tip of the cone out to the edge on the top. That would be the slant height, okay? So I'm just going to finish color coding this. RR, okay. So to find the surface area of this cone, we need to do pi r squared. The reason why it's pi r squared, some of you are wondering, is because that's how you find the area of a circle. This first red part will take into account this, okay? And this back part here, pi rs, will take into account this part up here. So pi r squared, well, our radius is 8. So 8 squared will go there, plus pi, our radius again is 8, and our slant height is 17.9. 17.9. And all we got to do, I would advise using the calculator for this part, okay? So you're going to do pi times 64 plus pi times, let's see what that'll give us. 8 times 17.9. 143.2. And let me calculate this next part. 64 times pi, or 64 times 3.14, will be 290 or 200.96 plus pi times 143.2. 449.88 roughly. Add those two together, you're going to get about 650.84 centimeters squared. Do not forget to square your label. So this cone takes up 650 roughly centimeters squared. So this part and this part take up that much. That's quite a bit. That's a pretty good sized cone if we got an answer that big, okay? All right, so this would be your next formula shortcut, and that's specifically for cones. Pi r squared plus pi rs, okay? All right, we are gonna do 3 more examples together. Looking at the timer, we've been going for 13 minutes. So the next 3 examples will probably take another 12 or 13 minutes. So if you wanna pause the video, come back at another time, feel free. Otherwise, we're going to keep going, okay? All right, number 5. This is a triangular prism, okay? So this is the example that I alluded to earlier. For this one, we're going to use the same formula that we used in question 2, which was perimeter times height plus 2 times the area of the base, okay? So first, let's find the perimeter of my base. So here's my base. I see my perimeter, I got 4 on this side. Since these 2 top parts are both 5, I know that both of these at the bottom are gonna also be 5 inches. So the perimeter of that base is going to be 4 plus 5 plus 5. I'm going to take that times the height of this prism. So the height would be 5. And I realize that some of these numbers that I'm pulling from, you're probably wondering why I'm picking specific ones. And the thing is, the more you can think about these shapes in your head or picture them, the easier it's going to be. Because we're looking at this shape kind of from a top angle now. We're looking down into it. If this was laying flat on a table and I was looking directly at it, it would almost kind of have a box shape to it. Okay, it won't have a point towards the top. So this would be the height. Okay, and now I need to take that plus 2 times the area of the base. So this base here is actually this time a triangle. And how do you find the area of a triangle? You need to take the base times the height and then divide by 2. So I'm going to do 3.7 times 5 and then take that, divide by 2. Okay? Whew, a lot of numbers going on here. So 4 plus 5 is 14. 14 times 5, that'll be that first part. And in the back, it's going to be 3.7 times 5 divided by 2. So 3.7 times 5 divided by 2 will be 9.25. Okay. Finally, 14 times 5 is going to be 70 plus, I believe that's 18.5. And you add those two together to get 88.5 inches squared. So again, this formula works for prisms. Triangular prisms like this one, and prisms that are kind of like boxes, like question 1 and question 2 and question 3, okay? All right, number 6, our next new formula. This is actually going to be a pyramid, okay? So just like the Egyptians built, just like we've all seen pictures of before. This is a pyramid, and pyramids are a little different. Surface area of pyramids, they're basically made of a square base and 4 triangles as their sides. So to find the surface area of a pyramid, we got to do this. We're going to do half of the perimeter times the slant height plus the base, or the area of the base. So I'm going to label some of these parts here for you again. Perimeter, perimeter of base. The red is the slant height, that measurement from the top down to the side, and the big B will be area of base, or the bottom. Okay, so we're going to do half of the perimeter of the base. Well, the base right here, that square, it's a square. So the perimeter would be all these sides added together. It looks like all these sides are 7. If this side here is 7, that side's 7. If this side is 7, that side's 7. So you're essentially doing 7 plus 7 plus 7 plus 7 times the slant height, which is given to us in red, 8.7, plus the base, which is the area of the base, and the area of the base is going to be the area of that square. So it'd be 49, or 7 times 7. Okay, let's clean this up a little bit. We're going to do half of the green, 7 plus 7 plus 7 plus 7 is 28, times 8.7, plus that back, 49, okay? And I'll try to keep it color-coded. So, grab your calculator. Half of 28 is 14. 14 times 8.7 is 121.8. That's this whole yellow part here. Plus 49. And that should equal 170.8 feet squared. Whew, got that one down. So that is how much space is being occupied by the outside of that pyramid. So here is our key formula. That would be another good one to write down. The reason why we're doing one of each of these types of problems is because you guys will be able to practice one of each on your own on the practice worksheet that we'll post, okay? All right, we have one more shape that we got to talk about, and it's my personal favorite. So without further ado, I'm going to erase the slide. One more example, then we're done. Here we go. Ooh, there it is. All right. Number 13. This is a cylinder. And a way you can think of a real life cylinder would be like a can. Any canned food you buy is essentially a cylinder shape, okay? Or like a can of pop, okay? So for cylinders, our surface area formula is 2 pi r squared plus 2 pi r h. Okay, again, the r stands for radius, so we're talking about circles, and h stands for the height of the cylinder. This one is kind of fun to break down. If you're wondering why it's 2 pi r squared, think about this cylinder. How many circles are there in this shape? There's one. There's 2 circles, okay? How do you find the area of a circle? Well, Mr. Willman, all you got to do is pi r squared. That's for one circle. But how many circles did you tell me there were? There's 2. So what are you thinking you got to do with this? Probably take it times 2. That would make sense, okay? So that takes into account the circles. The other part of the formula is a little trickier to understand. If you want to know where the other part of that formula comes from, feel free to email me or one of your teachers. That's kind of a fun part. Otherwise, we're not going to talk about it in this video, okay? All right, so let's start filling in what we know. What's the radius? Well, I know the diameter, this whole length is 20. I want to know just this part. If the whole thing is 20, that must mean the radius is 10. So I'm going to put a 10 here for the r, square it, plus 2 pi, again, 10 times the height of 13. So let's get out the calculator. 2 pi, 10 squared, so that's going to be 2 pi times 100, and 2 pi times, let's make that blue, 130. And now let's just type it into the calculator, see what we get. So 2 times pi, or 2 times 3.14, times 100 will give me roughly 628. And then if I do the second part, 2 times 3.14 times 130, that's going to give me roughly 816.4, okay? And from there, let's just add those two together. We're going to get a big number. 628 plus 816.4 will be 1444.4. Look at that. How often does that happen in math? That is special. It turns out this can or cylinder shape has a surface area of 1,444.4 meters squared. Wow, that is crazy. Whew. So, looking back at my note sheet, I think we covered everything that you guys will need to be successful. This would be the last note that you want to take, okay? Cylinder, surface area, 2 pi r squared plus 2 pi r h, okay? So you should have, I believe, 5 or 6 formulas that are going to help you find the surface area of various three-dimensional real-life shapes, okay? So take a look at the worksheet we posted on our Google site. There is an answer key provided, and the problems are worked out in a similar way to what I just showed you guys. So if you have any questions along the way, email your teacher. Otherwise, you guys should be good to go. Thank you for watching. We'll see you next time.